Lesson 11.6, Adding and Subtracting Rational Expressions, Day 2. Again, we are adding and subtracting rational expressions, only today they will not have like denominators to begin with. You will have to do something to them to make them have a common denominator before you can add or subtract. So let's review what you would do with something like 1/5 plus 1/2. They don't overlap with any common factors. Yesterday we saw that if they did have a common factor, then you would just multiply the other denominator by what was missing out of that denominator, top and bottom on both on that side that was missing it. Let's go that route. Okay, so 1/5 and 1/2 though, they don't have anything that overlaps. So what you would have to do is decide what the common denominator of 5 and 2 would be. That's just found by multiplying them together basically. So their common denominator would be 10. That would cause you then to multiply the left fraction, top and bottom, times 2 and get 2/10. And the right hand fraction, top and bottom, times 5, and you would get 5/10. And then you see now they do have a common denominator, so the common denominator, make sure that you leave the answer is going to have that denominator of 10. And then you add the numerators. 2 plus 5 is 7, and you always check at the end to see if anything reduces, and in this case it will not. Okay, so let's look to our first example, just some monomials. That'll start off simple. So 4x over 3y plus 2y over 15x. Now part of it does have a common factor because you know 3 does go into 15, right? So you want to find the so 3y and 15x. So what would be their least common multiple? So for the number part, what would it be? 3 and 15, we'd 15. Say 15. So that's a good thing because the right side already has the 15. So we only have to worry about the number on the left. And then the variables are completely different. So that means you have to include both of them. Okay? You have to include both of them. So my common denominator would be what? 15xy. So we want this denominator to be 15xy, and we want this denominator to be 15xy. So start out by trying to figure out what that common denominator is. It's going to have plus in the middle because there's a plus up there at the top. That's not going to change. All right. You have to ask yourself, what's missing out of 3y that would make it 15xy? Octavia?
5x.
5x. So over here on the left, I've got to multiply top and bottom by that part that's missing, 5x. So 5x times 4x would be 20x squared. On the right, what's missing out of 15x that is at 15xy? Avery?
Y.
The y. So multiply the top and bottom by that y. So 2y squared. Alright, now that I have that done, I'm going to combine them together. My denominator is just going to be one of the 15xy's. And the numerator, those are not like terms at all, so I would write 20x squared plus 2y squared. You still need to factor and see if anything cancels because it could happen. So out of 20x squared plus 2y squared, are there any greatest common factors, my tree? 2. So I'm going to factor out a 2. if I divided 2 out of the 20x squared, what's left? 10x squared. And if I divided 2 out of the 2y squared, what's left? Y squared. And then that would be over 15xy. And nothing cancels. Now, if the 15 was something even, do you see how you would reduce the 2 with that? So that could happen. So you really need to try to factor out greatest common factors or any of the reverse FOIL factoring if you need to do that. And see if anything cancels. But right now, you would have to finish off by saying this is your final answer. Questions about that? All right, let's scroll down here a little bit and see what's next. This one's a little more complicated, but not too much. So I have n plus 3 over n plus 5 times n plus 5 minus n minus 7 over n plus 5 and n minus 3. So here's the thing. You have got to determine what your least common multiple is. And the left has 2n plus 5s. So in your denominator, there's got to be 2 n plus 5s. On the right, there's an n plus 5 and an n plus 3. So there's got to be those two things. Now, the only thing that saves us here is there is an overlapping n plus 5. Okay? Do you get that? So you don't have to put 3 of them. That would be a mess. We only have to put 2 of them. So here is my least common multiple, or my greatest common, let's do my common denominator would be this. Let's write it like this. It would be n plus 5 and n plus 5 and n minus 3. Minus, and I'm going to have the same thing over here. Now when I go to start, when I go to start writing my final answer, I'm probably going to put n plus 5 squared just to kind of save some trouble. So n plus 5, n plus 5, and n minus 3. So we're thankful that one of those n plus 5s is in both, because you don't have to write it all the times then. If those fourth binomials would all be different, guess what? You'd have to write them all down, and that'd be a big mess. What?
So you're just adding n minus 3 to the other two?
Yeah. And then that way you've got both sides covered. You've got n plus 5, n plus 5, and n plus 5, n minus 3. Yes?
Say like the n plus 5 was like n plus 4, then you just have 4 on the bottom?
Yes. Yeah, we just said that. If they were all 4 different, then yes, you would have 4 binomials in your denominator. And that would be messier than this is already going to be. Okay, then.
Why wouldn't you, why would it be 1 n plus 5 or maybe it's 2 out?
I can't hear you. What?
Why is there 2 n plus 5s in the denominator on the one you wrote and not 1? I thought you would cancel out the n plus 5.
No. What you're trying to do is find a common denominator. And right now on the left, you have 2n plus 5s. So in our common denominator, you've got to have all of this. And you've got to have all of this. It's just we're lucky enough that this one is already there. So that's why I'm saying you're getting by with just putting 3 of those binomials down, n plus 5, n plus 5, and n minus 3. They're not going to cancel out. You're finding a common multiple of them. And you've got to include both sides. It's just that this and this overlap, so you only have to write it once. Okay? Okay, so we just said if they all 4 were something different, you would have to put all 4 in the denominator. But since there's a little overlap, you don't have to write that one out again. So if you look at this denominator, what's missing that's in our common denominator? Megan? n minus 3. So what happens over here is you've got to take n minus 3 times top and bottom. Well, we've already done it on the bottom because that's how we got that. But we have got to FOIL n minus 3 and n plus 3. And if you notice, like terms with different signs in the middle, so when I do outer, inner, what would happen?
The middle will fall out.
It would cancel out. So we're going to get a what? Difference of squares. So n squared minus 9. Okay, on the right, what's missing out of this denominator that's in my common denominator? What is it? An additional n plus 5, exactly. So n plus 5 on the top and the bottom. The bottom's already taken care of by nature of us writing that out. But now we have to take n minus 7 times n plus 5. So we're going to FOIL. So first is n squared, outer 5n, inner negative 7n, and last negative 35. Okay, so I can clean that up just a little bit over there on the right. So I'm going to do this. I'm going to do n squared minus 9 over, and I think I am going to go ahead and simplify this a little bit. N plus 5, I'm going to put a 2 there so I don't have to write it out all the times. N minus 3 minus, and then on the right I'm going to say n squared minus 2n minus 35, n plus 5 squared, n minus 3. Now it's time to combine the numerators. Here's the part I don't want you to mess up on. This right here. That is a minus. Please don't forget that. So I'm going to do this. My denominator, n plus 5 squared, n minus 3. Okay, let's start and do standard form. N squared minus n squared. What happens with that? Cancels out. Okay, there is no n term on the left. So it'd be like 0n. 0n minus negative 2n. What would that be?
Plus 2.
Plus 2n. And then the constant, negative 9 minus negative 35. What's that going to be?
26.
Plus 26. Okay, we're getting there, guys. My last thing is looking for any common factors. What is it there on the top?
2.
Take a 2 out just to see if anything cancels, and I'd have n plus 13. And then you put n plus 5 squared and n minus 3. So nope, nothing cancels. So that mess is your answer.
That's long.
That is long.
That seems simple.